All right, kids, Mr. Joseph's here. I'm just going to show you how to use these digital bingo chips to help you balance equations. This example that I'm showing you first is one that we have done before in our balancing equations activities. So each of these colors is going to represent an atom of element. So I'm going to choose this blue to be the hydrogen. Now you can just use Control C, Control V to make a copy. And then after you do that, you should highlight and group these elements. And so now you've got this as a total group together. All right, I'm going to choose green for my carbon. And then that means for my final one, I'm going to have 4 green surrounded by 4 blue. And you can see that I've grouped these together like so. Okay, now we can see that we don't have these balanced because we have only 2 hydrogen atoms on the reactant side and 4 on the product side. So we need to fix that. And the way we can do that, as you know, is to add another one of these groups. And so we're going to put a 2 in front of there, and now we've got this all balanced. Let's look at a second example. Okay, so I'm going to again make my hydrogen, and I'm going to group that together, and then my nitrogen. I'm using some shortcuts to group these. It might be slightly different with how you are going to do it. And then we've got this followed by, okay, make sure I do this right. And there we go, there's our different species. Okay, so now you can see there's only 2 on this side and 3 on this side, and then for the nitrogen there's 2 and only 1. So let's increase this 1 first. All right, so we're going to increase the whole thing because you have to do it in groups of these. And now I've got 2 greens on both sides, but my blues, the hydrogens, are not balanced. And so I'm going to increase that number. I'm going to keep going. Now I have 6 on each side. And now I can put my coefficients. I have 1, 2, 3 of these. I have 1 nitrogen, so I can leave that blank. Sometimes when you do answers, like on the balancing practice, you can put a 1 if you want to. And then over here, I can see that I have 2 of these. Okay, and then we'll do another example. In this example, we can notice that we have some polyatomic ions in here. And when we do a balancing of polyatomic ions, we should treat them as its own item. So I'm going to demonstrate that here. You may not be able to do this with your program that you might be using, but I'm going to make the whole polyatomic ion be considered green, and I'm just going to change this a little bit so we can see this. Okay, so that is going to be green. I'm going to use blue for my silver, and so you can see I have a silver and I have a green for the nitrate ion. And I'll group them together. And then I'm going to use red for my copper. All right. Then it comes this. And you can see I've got 2 of these nitrates over here. So I'm going to group that. Okay. Oh, where did I? Oh, this is not. Oh, I forgot something. How silly of me. We have to have silver still. The silver has to exist. I was rushing when I made this. So there's my copper nitrate and then silver over here. Okay, let's see. How can we balance these? We don't need these ones anymore. We'll just look at this. Okay, so what do we have that's not balanced? Well, we can see that the nitrates aren't balanced. We've got 2 over here, and we've only got 1 over here. So I'm actually going to double this silver nitrate. Okay, now I've got 2 silvers. Well, I can just double the silver. There we go. And does that appear balanced? I think it does. So now we can just put a 2 in front of here. Keep a 1 there and a 2 in front of the silver nitrate. And so you can see this only works if the polyatomic ion does not separate and come apart when it reacts. It's still a group of NO3 on both sides. It makes it a lot easier to solve these types of problems. All right, those are the 3 examples I have for you. Let me know if you have any further questions.